Welcome to Modern Dev episode 6, and today I will give you a short introduction to JUnit and unit testing in general. So I prepared something in order to save time. We have a simple class called adder with one public method called add, and the add method, as the name suggests, adds two numbers and returns the result. And now we want to test this functionality. So let's have a look at the corresponding test. So by convention, it's always a good idea to put the test for the class in the same package. So here we have the default Java, the org.example package, which was generated by IntelliJ by default here. So the test class is in the same package in the test folder. So that's good best practice. I would also suggest naming the test, naming the class the same as the subject under test. So your class is called adder. Therefore, your test class will be called adder test. And now we have one method, which is also called a test case. And the only thing you need to do is you need JUnit on your class path. And then you only need a method. You don't have to declare it public, and you just annotate it with the add test annotation from the JUnit Jupyter API. And this is enough so that you can run the tests with your IDE if it's set up correctly, or run it with Gradle on the command line. So besides that, so you have a method that you annotate with add test. Then by the behavior-driven development suggests you should start names with should, because it has some advantages. So it makes the test case more self-explaining, and also you have to think a bit more about actually what you want to do when you started with should. And that's how somehow forces you to think more, what you want to do. So in order, what you want to test here. And so in this example, we want to add two numbers. So we say should add two numbers, for example. Or you could also say should add 2 and 3. And so everybody who reads that, knows exactly what's going on. If this test fails, you have a pretty good idea what's probably the problem here. And so what's very typical with tests, you have 3 stages, so to say, or you have 3 parts. You have given, when, then, and that's doesn't matter what framework you use or what language. A test case always has these 3 steps. So you have some preconditions, stuff that you need in order to run the test, these things are the given part. The when part is actually where you execute the thing that you want to test. So if you test a class, like in this case, we test the adder class, that means for a method, you have one test case. So let's say you have a class with 3 methods. That would mean if you want to have at least one test for each method, that you have 3 test cases. Usually you should have more than just one test, at least a good case test and a bad case test that tests for errors, for example, or edge cases, something like that. But in one test case, you test one method of the class that you are testing. And this method is called in the when part, and in the then part, that's the part where you basically express your expectations. What do you expect that's supposed to happen after this method was called? So in this case, we want to compare the result of the add method with a value that we expect. And that's what we're going to do here. So I would also, when you use JUnit, I would strongly recommend also using the AssertJ library, because this gives you some very nice helpers for comparing your results, like some matchers. It just makes the whole thing more readable. Like this assert that's a functionality that comes from the AssertJ library. And then you can just express things like this: assert that result is equal to 10. So it almost reads like an English sentence. And they have a lot of other matchers in this AssertJ library. For example, for comparing lists, there's really nice stuff in there that makes your tests much more readable, much more concise, easier to write. That's would really recommend having a look on AssertJ. You can also make a video about AssertJ if you want. So tell me in the comments. And so that's basically your setup. So we instantiate our class. That's the only thing we have to do in the given part here. There's nothing more to do. Then in the when part, we call it. And in the then part, we expect the result. And so now I'm using IntelliJ here. So there are several ways where you can run the test. You can make a click here on the tab and say run adder test. And it will run it. And now we get an error message because it says expected 10, actual 7. So as you can see here, we expect the result to be 10, which is wrong, because like 3 plus 4 is 7 and our add method does the correct thing. So that's why it returns 7 here, but we compare it to 10. That's why we get a failing test here. And that's also like a very good practice. Like never trust, there's a saying, like never trust a test that you haven't seen failing. So it's always a very, very good best practice to start with a failing test and then fix it. Usually that also goes hand in hand with test-driven development. I will not talk about this now, but in a later episode. So, but now we see it fails. So now we change 10 to 7 because that's what we expect if we add 3 plus 4. And that's also what is returned by our add method. So now the test is green because our functionality works. Yeah, that's the very basic setup and a very basic example of JUnit. There's much more you can do with it. I will cover this in following videos. So if you like this video, please give me a thumb up or write me a comment if you have questions or what you want to see next time. And yeah, subscribe to the channel. And thanks for watching. See you next time.